Alright guys, this video is still continuation of 3.4. We are now moving on to marginal cost and marginal revenue. So the first one we're going to start with is the marginal cost. Okay, so marginal cost is usually cost of production, making stuff, right? Which is the rate of change of cost with respect to the level of production. Okay, let's call it dC over dx, where C of x is the cost needed to make X products. Sometimes marginal cost is also defined as the extra cost of producing one more unit. Okay, and that's important. So let's go on to marginal revenue. Well, marginal cost is the expense. Marginal revenue is when you take in money. So marginal revenue is the money gain by selling one more unit. And again, that's really important, right? So which normally you're going to see is the derivative of revenue with respect to x, where R of x is the revenue collected by selling X product. Okay, so I want to highlight this thing right here. The marginal cost is defined as extra cost of producing one more unit. Marginal revenue is the money gain, okay? Money gain by selling one more unit. So make sure you understand what marginal cost is and what marginal revenue is, okay? Let's go on to this example, and let's change this to 7. Suppose that the dollar cost of producing X washing machines is given by this equation. C of X equals 2,000 plus 100X minus 0.1X squared. A, find the average cost of producing 100 washing machines. So I'm going to write down the average cost. So let's find that first. Average cost is going to be of producing 100 machines. Okay, I'm going to take the cost of 100 machines and then divide it by 100. Okay, so let's go find what the cost of 100 machine is. Okay, so here we go. C of 100 machines, let's plug in 100, so that's 2,000 plus 100 times 100, because I'm producing 100 machines, minus 0.1 times 100 square. Okay, now I'm going to punch it all in my calculator. So that's just the cost of 100. Now I have to go and divide this by 100, right? So divide this by 100, which is now 100 here. I'm going to punch it in my calculator, and my calculator spits out $110. Now, this is $110 per machine on average, okay? Remember, it's not producing one more machine, it's on average. Keep that in mind. So the average cost of producing one of the machines, it's $110 per machine, okay? Now, part B is slightly different, as you can see. Part B says find the marginal cost, okay? Marginal cost when 100 machines are produced. What this really mean, class, is producing one more. So let me just write a full sentence here, and then we'll fill in the number after. The cost of producing one more, okay? One more, which is really 101 machine is. I'll just highlight this and we'll fill that in at the end when we're done doing our math, okay? So based on our definition of marginal cost and marginal revenue, we have to take the derivative. So the derivative of 2000 is a constant. Derivative 100x is just now just 100 minus 0.1 times 2x. So that's going to give me c prime of x equals 100 minus, if you take negative, or you take 0.1 times 2, it's just going to be 0.2x, okay? Now I'm just going to plug in c prime of 100, which is 100 minus 0.2 times 100, okay, which is, that's going to give me, let's see, that's going to be $80, okay? So by some basic math here, that's going to be 80, because 0.2 times 100 is 20. 20 take away from 100 is now 80, okay? So as you can see, the cost of producing one more machine, which is 101 machine, is really just $80, okay? $80. So it's very different from the average cost of producing 100 washing machines, okay? Now, let's go to this one, C. Show that the marginal cost when 100 machines are produced is approximately the cost of producing one more washing machines after the first 100 have been made by calculating the latter cost directly. So what this means is really proving, okay, we're trying to prove part B by doing some algebra stuff, okay? So it says show that means I'm trying to prove, right, why the marginal cost, which is producing the 101th machine, is only $80 by doing some calculation, okay, by doing some algebra work. So what I want to do is, obviously, I want to calculate the cost of producing 101 machines, okay, total. If I can take that cost from producing the 100 machines, so what I want to do is I want to see, hey, if I were to go and produce 101 machines, and I want to go and take the calculation of producing 100 machines and subtract one from another, is it going to give me the marginal cost, okay? So here is what we're going to do. We're going to do the basic math slowly, okay? So let's plug in, what was the equation? 2000. So 2000 plus 100 times 101 minus 0.1 times 101 square. So that's just one part. That's when we are producing 101 machines, okay? Take away. Now let's take away the cost of producing 100 machines to see if the difference is about the marginal cost from part B. 2000 plus 100 times 100 minus 0.1 times 100 square, okay? I'm going to use my trusty calculator, cautiously punching this in. So when you punch this all in, class, your calculator should show that it's going to be 79.90. Now, obviously, it's not exactly 80, but it's pretty darn close, right? So as you can see, the derivative is a much quicker way of getting the marginal cost than doing it algebraically. And so just like, remember, derivative is using limits, and limit is an approximation, right? So that's why it's close, but not exactly the same. And that's okay. The difference is so small that it's not that important. So that's why we use calculus, which is derivative, to find marginal cost or marginal revenue, okay? Let's move on to this last bit here. Summary of code words for derivative, okay? If I ask you to find the rate of, so the rate of change, okay? Growth rate, rate in which, ... How fast is it going? How fast is it changing? Or the marginal cost, marginal revenue. Those are all derivatives, okay? Now, also, if I ask you to find the velocity, which is the derivative of the position, okay? Find the derivative of a position, obviously that is the velocity. If I ask you to find the acceleration, which is the derivative of velocity, which is the second derivative of position, okay? So that is the end of, ooh, look at that. That's the end of 3.4.